In this presentation, we will see the next relational algebra fundamental operation, the relational algebra union operation. We know basically there are 6 fundamental relational algebra operations, and we have already seen about the first 2 operations, the select and project operations, in the previous lectures. Now we are going to focus on the third fundamental operation, which is the union operation. Let's see the theoretical aspects of this union operation now. And we have already seen this point in the last presentation that any relation is a set. A relation in DBMS is having a close correspondence or close association with the mathematical concept called the set. And when we talk about the union operation in relational algebra, this union operation is similar to the union operation in the set theory. And that's why I told you any relation is a set. And this union operation, what we are focusing on in this presentation, is similar to the union operation in set theory. And what type of operator is this union operator? Is it a unary or a binary operator? The name itself says that it is going to do the union operation. It means it requires at least 2 tables to perform the operation, isn't it? So it is a binary operator where it requires 2 inputs. To be precise, it requires 2 tables or 2 relations to perform the operation. Say we have 2 relations A and B, and what's the output of A union B? That's what we are going to see now. It is a set of all objects that are a member of A or B or both. If we take A as a relation and B as another relation and we perform A union B, then the output is going to be the set of all objects or all tuples that are a member of A or B or both. No worries, when we see an example, at the time it will be easy to understand. But for now, just understand, when we are performing A union B, the output will be containing the members from A as well as the members from B. And there are situations where the values may be appearing in both A and B. Will we be having duplicate values? No, we will not be having duplicate values. So like the project operation, here also the duplicate rows are eliminated. Let's say A is containing some list of fruits. Say for example, apple, mango and grapes. And B contains apple and strawberry. And when we perform A union B, we will be getting apple only once. Why? Even though the fruit apple is in both the sets A and B, but still we will be getting only one apple in the resultant. And that's why I told you, the values in the output will be the member of A or B or even both. But if there are duplicate values, these duplicate values are eliminated in the resultant table. And what is the symbol which is used to denote the union operation? This is the symbol, the union symbol, which is used to denote the union operation. Let's see the syntax now. When we talk about union, we cannot directly apply union on 2 different relations. Let's say A is a relation and B is another relation. Can we directly perform A union B? We need to ensure certain conditions are met because we cannot directly perform A union B. The number of attributes in A may be different from the number of attributes in B. Say for example, if A contains 5 attributes and B contains 4 attributes, in this case A union B cannot be performed. Then how it will be helpful? Just see the syntax, it will be easy. We are not directly performing relation 1 union relation 2. Rather, we are performing the projection of a single column or multiple columns from relation 1 that is performed with the union with another projection. It may be a single column or a group of columns from another relation, which is relation 2 in this example. So what we are actually doing here is, we are going to project a column from relation 1, union, and we are going to project another column from relation 2, and the output of this will be single column, and the output of this will be single column, and we are going to perform one column union another column. Remember, the output of this will be a relation only. And the output of this is also going to be a relation only. So we are going to perform union between relations, but not directly. When we see an example, we will be able to understand things clearly. Let's first understand the operation of union with simple example. Let's say we have a relation R which contain only one attribute, and this attribute is alphabets A, B, C, E and F. Let's take another relation which is S, and this relation is having a column or an attribute which is characters, and the characters are A, B, $, E, F1 and hash symbol. Now what we are going to perform is R union yes. Can we do R union yes? Yes, there are certain conditions to be met, but at the basic level, the first condition will be satisfied. The number of attributes in R is same as that of the number of attributes in yes. So here also we have only one attribute in the relation. Here also we have only one attribute in the relation. So R union yes can be performed. But still we have another condition to be satisfied before applying union, which we will see at the end of this presentation. For now, just understand, I am going to apply R union yes. Let's see the output of R union yes. And the output is going to be R union yes. Let's see what's the data present in this R union yes relation. Say A, B, C, E, F. So all these values will appear in the output relation A, B, C, E and F. Now the members of R is present. All the members of R is present in the output relation. Now we need to ensure whether all the members of yes are also present in the output relation. Talking about the first member A, which is already there in the output relation, as per the concept of union, the duplicate values are eliminated. So this A will not be appearing again in this output relation. Likewise B, because B is also already there in the output relation. And talking about dollar is not there in R, but it is there in yes. So dollar will be there in the output relation. Coming to E and F are already there in R, which is already sent to the output R union yes. Which is already available in the output relation. So E and F will not be appearing again because it's a duplicate value now. So this will be eliminated. Then coming to 1, if you see 1 is there only in yes and not in R. So 1 will also be there in the output. And coming to the hash symbol, this hash symbol is not available in the relation R but available in S. So this will also be available in the output table. So this is the working of R union S. In simple terms, if we consider two relations R and S, the output will be containing the members of R or the members of S or both. So this example is just for understanding purpose. With this knowledge, let's see the formal example. The question is, list all customer names associated with the bank either as an account holder or a loan borrower. Just pause this video for a while and think what are the two relations that we are talking about in this question. I hope you are done. The example relations that we are talking here is one is related to the account holder and the other one is related to the loan. So what we are assuming here is there are two relations. One is the depositor relation. So I am saying if somebody is having an account in the bank, it means that person is having a depositor relationship with the bank. So here is the depositor relation. And if somebody has availed a loan from the bank, so obviously he is a borrower, right? So he is the loan borrower. So I am considering these two relations are existing. Number 1, the depositor, and number 2, the borrower. And what we are required to find? We are required to find the list of all customer names associated with the bank either as an account holder or as a loan borrower. Let's say there is a customer X. If that name X, it should appear either in the account relation or in the depositor relation. It may even appear in both the relations. But our output should contain the value X. Let's solve this problem now. So what we are doing is we are considering this depositor relation and we are retrieving only customer name from the depositor relation, which is this part. So all the depositors' name will be appearing here. Just see what operator I have used. The project operator. So this project retrieves only the customer names from this depositor relation. And the output of this is going to be a relation, a temporary relation, which contains only one attribute, which is customer name. And coming to this side, here I am focusing on the borrower relation, and in the borrower relation I am retrieving only the customer names from the borrower table or borrower relation. And here what operator I am using? The same project operator. Please note, the depositor relation may contain X number of attributes and the borrower relation may contain Y number of attributes. Y and X may not be the same. But here we are not doing depositor union borrower. We are doing customer name union customer name only, where this customer name is from depositor relation and this customer name is from borrower relation. And the output of this expression is going to be a table with only one attribute, and the output of this expression is going to be only one relation with one attribute, and we can perform union. So here is the output for this query. So generally when questions are asked, just make an assumption what could be the table name and just start proceeding with the expression. If table names are not explicitly mentioned, we can make assumptions on the table name and we can proceed with the expressions. To understand things clearly, let me elaborate the solution with an example table. Let's take this is the depositor table which contains two attributes, customer name and account number, which is this relation. Let's take this relation, the borrower relation, which contains two attributes, customer name and loan number. Are we going to do depositor union borrower? Depositor union borrower may be proceeded with because it also has two attributes and this also has two attributes, but still we have other conditions to be checked before proceeding with depositor union borrower. Let's not touch upon that part now. But for now, just understand, we are not going to proceed with depositor union borrower. Rather, we are going to proceed with projection of customer name from depositor, union, projecting customer name from borrower. It means I am going to do union only for these two columns. This one, union, this one. Let me give a naming convention for easy readability. Let this be R and let this be S. So what is R? It's the customer name from depositor relation. So what I am doing is I am just renaming this output as R, which is this. So this R contains only the customer names from depositor relation. And this S contains the customer name only from borrower relation. And this is R, this is S. So what I am going to perform is R union S, which is the customer name. So Tom, Amy, Rose, John. Tom, Amy, Rose, John. It's appearing here. Then coming to this place, John is already there in the table. So this will be ignored. This will be eliminated because this is a duplicate value. Coming to Smith is not there already in the output table. So Smith will be added. Coming to Rose is already there in the output table. So Rose will also be eliminated. And coming to Jack is not already there in the output table. In other words, Jack is not there in the first table. And hence Jack will be added to the output. And this is the output of R union yes. Before seeing the other example, I will show you the schema. Just pause this video for a while and have a look at the schema. I hope you are done. Now let's proceed with the next example. The question is, find the set of all courses taught in the fall 2009 semester, the spring 2010 semester, or both. What we are required to find? We are required to find the set of all courses. And these courses may be taught either in fall 2009 semester or in the spring 2010 semester or both. Now from which table we need to perform all this operation? If you want, I'll just show you the table, just think about it. So from which relation we are going to retrieve the data? Section is the relation where this contains the course as well as the semester as well as the year which has been taught, right? So I am going to take the list of all courses that are taught in this particular semester and in this particular year from this relation section. So the answer for this part is going to be the project operation, and before that what we need to do? From the section relation we are going to retrieve all the courses that are taught in the semester fall and in the year 2009. So what I am doing is, first I am retrieving all the tuples where the semester is fall and giving AND condition because in this fall and 2009 year. So I am selecting all the tuples where the semester is fall and the year is 2009 from the section relation. So this will give all the tuples, and what I need? Only the set of all courses, right? So course ID, I need the course ID. So I am just projecting only course ID from this output temporary relation. Remember, this temporary relation will contain the set of all tuples with all attributes. From those attributes, I am retrieving only course ID. So this is for this semester fall 2009. We need to do the same for spring 2010. So the query goes like this. To find the set of all courses taught in the spring 2010 semester, we write select semester is equal to spring because we are focusing on this part, and year is equal to 2010 and year is equal to 2010. From the section relation, the output of this inner query is going to be a temporary relation with the tuples with all attributes. And from this I am going to project only one attribute, which is course ID. Now this query gives the output of all the course ID that is taught in fall 2009. This query gives the output of all course ID that are taught in spring 2010. And what's the question? We need to list all the courses that are taught in fall 2009, spring 2010 or both. In that case, to answer this query, we need the union of these two sets. So the output of this is this part, which is this part, union this part, which is this. So the output is going to be the set of all courses taught in fall 2009 semester, the spring 2010 semester or both. Before we sign out, let's see the two important conditions to be valid for performing the union between two tables. The two important conditions. For what? For R union yes to be valid. I mean, R is a relation here and S is a relation here. For R union yes to be valid, then these two conditions should be met. First, R and S must be of same arity. What do we mean by this? It means the number of columns in R and the number of columns in S must be the same. In simple terms, the number of columns in both the relations R and S should be the same. For example, if the relation R contains 10 attributes and the relation S contains 5 attributes, R union S is not possible because the first condition itself is the number of attributes on R and S must be the same. Let's say if the number of attributes are matching, then can we directly perform R union yes? No, we cannot directly perform R union yes. So the next condition is for all I, the domain of the ith attribute of R should be the same as that of the domain of ith attribute of yes. What do we mean by this? Let's say there are two relations R and S, and R contains 3 attributes and S also contains 3 attributes. So the first condition is satisfied. Both R and S must be of same arity? Yes. R and S has 3 columns each. And coming to the second condition, the domain of ith attribute of R should be the same as that of the domain of ith attribute of yes. It means the domain of the first attribute of the relation R should be the same as that of the domain of the first attribute of yes. The domain of the second attribute of the relation R should be the same as that of the domain of the second attribute of the relation yes. So likewise, all the attributes according to their position should be belonging to the same domain. When these two conditions are met, R union yes is possible. But in our example, we have not simply performed union between two relations directly. Rather, we have projected the output, the temporary output, and then we perform the union among these two outputs. And that's it, guys. Before we sign out, let's see the homework questions. Here we have two homework questions. Let's see what are they. Before seeing the questions, I wanted to introduce the schema that we are familiar with. This is the university database schema where we have multiple relations: instructor, course, department, section, teachers, student, advisor, takes, classroom, and time slot. Question number 1, which is list all the course IDs which are taken in spring 2020 or fall 2021 semester. So this is a pretty straightforward question because we are going to find all the course IDs which are taken in spring semester year 2020 or fall semester year 2021. We can easily answer this question number 1 because it's a simple projection along with union. Only thing is we are required to find the right table or the right relation and the right attributes for the condition spring 2020 or fall 2021. And coming to question number 2, list all the instructors ID who taught courses in spring 2020 or fall 2021. And question number 2 is a bit tricky question because we are required to find all the instructor IDs. But the tricky part is the instructor's ID are available in multiple relations. Can you see here, this instructor relation also has ID. And coming to teacher's relation, this also has ID. And coming to advisor relation, this also has ID. I am not bothering about this because this ID represents student. So what I mean to say here is we have instructor's ID in multiple relations, and the challenge is to find the appropriate table that contains the information about the courses that the instructor has taught in spring 2020 semester or fall 2021 semester. I request you to meticulously look into the questions and post your answers in the comment section. And these kind of questions will definitely help us to crack the competitive examination questions. And that's it, guys. In today's presentation, we have focused on the union operation in relational algebra. In the next presentation, we will focus on the set difference operation, which is also one of the important operations in relational algebra. And that's it, guys. I hope you guys enjoyed this presentation and thank you for watching.